Hey everyone, welcome back to my channel. Today we're going to solve the easy level problem reverse linked list. So we're given the head of a single linked list. We need to create an algorithm to reverse the whole list and return the reversed one. So basically the operation we're going to do is literally just output the whole list in a reversed order. Although this is an easy level problem, I think it's a crucial one because many problems are based on the reverse operation, which means it's the subproblem of many other questions. It's just like the binary search, which we need to implement the algorithm as quickly as possible. We can do this with two-pointer technique. So let's see how it works. Well, let's say with the respective of the node 2, instead of pointing to the next node 3, we want to make the pointer to point to the previous element, which is 1. In this situation, we can use two-pointer technique to achieve this. We will have a current pointer, which points to the current element that we are visiting, and another pointer called previous, which point to the element before the current element. So in this case, it's null. In order to achieve the reverse operation, we will take the next pointer of the current one, which means we will break the link here and make it point to the previous one. And then we will shift pointers. The current will be shifted to the next element. In the same way, the previous pointer should be pointed to the current position in last step. So how are we going to achieve this? I will show you in the code section. So then we move to the node 2. So basically the same thing. We will take the pointer and we'll make it point to the previous element. And then we will shift current pointer to 3 and shift the previous pointer to 2. And now for 3, because the next node is now, we will end our iteration in the next step. But we will still conduct the same process as the previous one. So we will still take the next pointer and make it point to the previous 2, and then shift the current pointer to the next element, which is null, and the previous pointer will be at 3. Okay, so because our current element is null, we will end our iteration. So basically we finish our whole reverse operation. So how do we return the result? Luckily, we can see the previous pointer, which points to 3, and we can see that 3 points to 2 points 1, and 1 points to the null. It's the whole list we want to return, right? We're gonna literally just return the previous pointer, and we will get the correct answer. Let's see how to implement the algorithm in code. Like what we said in the drawing, we will have two pointers to iteratively shift them to do the reverse operation. So the previous one and the current pointer. So initially, the previous pointer will be set to null, which is none in Python. And the current pointer, we will point it to the head. Remember in the drawing, the shifts of the pointers will not be stopped until we reach the last element, and the current pointer will point to null. So how to represent it in the code? It just use a while loop. We will continue the iteration until the current pointer points to null. The first thing we want to do is to take the next pointer and point it to the previous element. So we will set the next pointer of the current node to the previous one. And then we will shift the pointers. So the previous one will be the current one, and the current will be current next. But one thing we need to mention is that because we update the current next to the previous node, so we can't do this here. So how do we gonna do? We will use a variable called next node to contain the node that is next to the original current node. Then here, we will use the next node and give the value to the current. So in this way, we will shift our pointers iteratively. When the current pointer reaches the end and points to null, we finish our iteration. Remember, how do we return the result? We will return the previous pointer. Okay. So the implement is not that complex, but the idea behind it is very important. So our goal is to understand the code and the principle behind the code and implement the algorithm as quickly as possible in our interview.